Hi everybody, Steven here. This is part 3 of the vSphere performance playlist that I put together. In this episode, we're going to take a look at monitoring CPU performance, one of the common things that you're probably going to want to do. But more importantly, we're going to take a look at the architecture, talk about certain terms, explain what they mean. Then we'll look at the various counters that we should be examining and what they mean and what could not be a problem, okay? So stick around and we'll see you in a bit. Bye-bye. Hi everybody, thanks for sticking around. So in this episode, as I mentioned, we're going to take a look at the first component is CPU. I'll have videos on memory, disk, and network and things that we have to watch out for there. But hey, let's learn how to walk before we run, right? So let's take a look at CPU information, right? Now, before we jump into certain terminologies and stuff, I got a bit of a lecture and a demo here. I always like to throw this out at this point. If you haven't subscribed to the channel, please support the channel by subscribing to it. Without subscribers, there's really no content developers, right? So, and it's free. Just click that subscribe button. Another way to support the channel is also the super thanks, but that's totally up to you. And share these videos. That also helps out as well. So, but subscribing does help out. All right. So why don't we jump into it? Let me get my iPad up here. So there we go. Let's jump in and talk about CPU. Now, first thing I like to just point out here, we've got our VMs. It's sitting on top of our hypervisor here, and your hypervisor is sitting on some type of physical server, right? Now, inside your VM, you've got your various resources, CPU, memory, disk, and network, and you have your operating system. One of the things you got to keep in the back of your mind is your operating system doesn't know it's virtualized. It thinks it has access to all of this hardware and it's privately owned, right? It doesn't know anything about being virtualized. So you have to kind of be aware of that. So since we're talking about CPU, these VMs basically are all sharing the CPU resources. I'm only showing one here, but maybe you have many, right? Now, first of all, before we jump into this, let's talk about what a world is. You might have heard of that term. If I said, let's say, if we're talking about Windows and I said, oh, I found a process that's acting up or a process that's locked, you'd probably know what I'm talking about, right? A world from an ESXi perspective, a virtual machine is really just a process, but we call them worlds, okay? So a virtual machine is a world. It's very much like a process. We schedule this on a processor, a physical processor that's available, right? So a virtual machine is basically a group of worlds, a group of processes, right? Just like you may have an application that may have multiple processes or threads that are running, okay? For example, this is just a list of few, and you may or may not see these depending on your VMs and stuff like that, but each virtual CPU you give a VM is also a process. So you'll actually see one for the first processor, second, third, depending on how many virtual CPUs you give the VM. You'll see one for the mouse, keyboard, and screen. You'll see one, here's a memory scanning process, there's the mouse, there's a video, looks like there's a disk controller. There's a few processes that make up a VM. And these things have to get scheduled out onto the physical CPU. So you got your VM kernel port over here. It's not a kernel port, sorry. You got the kernel on your host, your ESXi host, and it does all this scheduling. It has this built-in scheduler which chooses what world to schedule on what processor. Okay, that kind of makes sense. So a VM is a process and it's got to be scheduled out onto a physical processor. Okay, great. So inside the kernel, VM kernel, there's that scheduler, and it's responsible for choosing which world to be scheduled on a processor. I talked about shares, limits, and reservations in part 2. So if you haven't seen that, you got to go back and watch that, okay? So we've got ways of prioritizing our VMs, and one of the methods is shares, limits, and shares, limits, and reservations, sorry, right? So the scheduler will schedule your virtual CPU onto physical processors. So we see over here, this VM has one virtual CPU. So the VM kernel will say, I need to schedule it out on my processor. Notice this one has 2 and this one has 4. It's going to check, the scheduler is going to check every 2 to 40 milliseconds and migrate any virtual CPU. So it's going to check and see if we need to schedule any out or migrate them off. Remember, this virtual CPU can run on pretty much any processor, logical processor, that's on your host, unless you did something like Affinity, which I demoed back in part 2, right? Which you don't want to do that. That's not good. Now, let's take a look at the processor. Let me just zoom in a little bit on that. Okay. So here I'm just showing you a single socket server. So if you look at the motherboard, it's got a socket, just one socket, and a chip goes on it. And that's where your processor is. And you've heard of terms like, oh, it's got this many cores and so many threads. So in this example, I'm showing you cores. I got 4 cores, and a thread would be something like hyper-threading. Now, kind of the definition of this stuff, back in the old days, again, way back when, you basically had there was no cores, no like multi-cores. There was no hyper-threading, or all that kind of stuff. Your processor, the chip on the motherboard, had its processor, and it just did one thing at a time. That was it. It wasn't multi-core and hyper-threading and all that. None of that stuff existed. So if you had 2 sockets on your motherboard, you had 2 engines, and it could execute 2 threads at the same time, or 2 processes at the same time, and that was it. If you had 4, you could do up to 4. That was the old days. I can't remember what came first, cores or threads, but it doesn't really matter. But then Intel, AMD came out, and they said, you know what? On that same die, that same chip, we can put another engine, so we can have like multi-core. So we got a single socket and then 2 cores. That means there's like 2 built-in processors on that same die. So now they can do things a little better and a little faster. But remember, they're still sharing some of the features of that die. I'm not going to get into it because it all, maybe the L2 cache, L3 cache, all that kind of stuff. And as time has gone on, we've got like stuff, 24 cores and 48 threads. It's gotten really crazy, right? So you got to be aware of that terminology, right? So when I'm talking about cores here, now, first of all, so a core is like a second engine, or third or fourth or fifth or whatever, that can execute instructions. Then along came hyper-threading, okay? Intel announced that. I forget what AMD's version is. It doesn't really matter. I'll be honest with you, most of my server experience came from Intel platforms, because that was basically the most common one out there back in the day. Hyper-threading was like a virtual CPU. So if I said, oh, I've got a single socket and a single core, and I got hyper-threading, it would say, oh, you've got 2. You could execute 2 instructions or 2 threads. So it looked like I had 2 cores, but I didn't. I had really 1 core, and I kind of had like a virtual core. It didn't double my performance. Maybe, again, technology has improved over the last bunch of years, but maybe you can get like, 20 or 30% increase in performance. So that was kind of neat. So hyper-threading is kind of a good thing. Generally, you don't have to disable it, but just ignore that it's there. Don't count it as one of these cores, okay? So in my example here, my little picture, if we zoom in, let's just move this over a little bit. Notice I've got 3 VMs. I got one with 1 processor, another one with 2, and another one with 4. So again, let's say I'm going to schedule this guy over on, let's say the kernel's going to schedule this guy on that core. Now it's going to schedule these 2. Now I'm just going to say this right now, and I'm going to correct myself. So it's going to schedule both of these on 2 different cores, okay? Now what about this guy over here? Well, it basically has to find 4 available processors to scale to schedule it across. It only has 1, so it can't really do that. So this is in a situation. Again, let's say all of these machines need access to the processor. This is a situation where you can run into problems. Now, I talked about shares, and for each virtual CPU, you get 1,000 shares. So this guy would have 1,000. This guy's got 2 virtual CPUs. He'd have 2,000. This guy would actually have 4,000. So technically, he should be able to get higher priority. But remember, it's not like a reservation. It's not guaranteed, okay? So one of the things you really got to watch out for is if you get into a situation where you've got your physical server and it's got limited resources for CPU. Forget about hyper-threading. Don't bring that into the picture. Just think of that as like an ace up your sleeve, okay? It will schedule these cores on a hyper-threaded virtual CPU, or I shouldn't say virtual. It will schedule these virtual CPUs on a hyper-threaded core, I'll say. It knows that it's not the greatest, and it tries to avoid that, okay? But if it's got no choice, it's got no choice. But let's forget about hyper-threading in this picture. So right now, if this physical server has limited CPU, all of these guys can't run at the same time. Something's got to give, right? And what's going to happen here is these VMs are going to suffer from it. This, for example, let me just change my colors. This VM over here, this processor might be ready. It might be ready for a physical processor, but the kernel can't schedule it out because it says, I don't have anything there. So there's a counter called the CPU ready. That's one of the ones that we have to look at. And I've got this summarized at the end, so don't worry, right? Now, another thing is, let's say this machine's really oversubscribed. Okay, we got so many VMs on it, it's oversubscribed. The CPU is glowing red hot because it's so busy, right? You got to ask yourself this question. Do you think, let me clear up all this garbage, do you think it's easier for VM kernel to schedule all of these 4 processors, or is it easier to schedule these? So maybe you got a bunch of single virtual CPU VMs. It may say, you know what, let's schedule those, get it out of the way. This guy may have to wait a bit. It may have a harder time getting scheduled. Okay, so keep that in the back of your mind, right? So there's a thing called ESX, there's a thing called co-scheduling. Okay, you may have heard that term. So it's optimized to run symmetrical multiprocessing SMP virtual machines. So that would be like this one here and this one here. So any virtual machine that has more than one virtual processor is an SMP virtual machine. And you got to remember, back this operating system inside your VM says, oh, I've got 2 processors, or I got 4, I got 8. It thinks it has those, and it's dedicated to its task. So it's going to expect those processors to be running synchronized, right? They should be synchronized. They're all mine, right? Shouldn't be any problems. But we know in a virtual environment that's not the case. So this co-scheduling was introduced, I can't remember when, way back when. It might have been back in the ESX 2.0 days, or maybe even 1.5. I can't remember. Doesn't matter. So co-scheduling allows the ESXi server to say, okay, you know what? I can actually support multiple virtual CPUs and schedule them out. Now, co-scheduling used when a VM has multiple virtual CPU ensures that the related processes run on different processors at the same time. So ideally, when we schedule this VM out, these 4 processors need to be scheduled across all 4 of those cores. Again, let's forget about hyper-threading. Okay, it could do it, but it knows it's not the greatest. But okay, keep that in the back of your mind. Now, co-scheduling, only virtual CPUs that are skewed are co-started. Ooh, co-scheduling, skewed, and co-started. What the heck's all that about? All right, so there's a thing called skewing. Since we've got these 3 VMs beating up this processor, let's say this VM over here, again, let's say we're scheduled on this one, this guy, let me just redo this. Let's say this guy's scheduled here, this guy's scheduled here, but we're only got 2 of these guys scheduled over here. Generally what happens is, back in the old days, we would say, okay, and I can't remember what version, it might have been version 2 and 3, if I remember correctly. Please correct me if I'm wrong. It would say, okay, this VM here has 4 virtual CPUs. I need to schedule all 4 of them out there at the same time. Okay, that's co-scheduling. What is skewing? Skewing means is, well, let's say one of those processors is falling behind a little bit. Maybe I had to schedule this guy over here temporarily, right? So now one of the processors in this VM is running behind a little bit compared to the others. That's called skewing, and that's okay to a certain degree. I forget what the threshold is. It doesn't really matter because it's really probably based on the operating system. But the skewing is basically when these processors are executing at a different rate. So one's kind of running ahead in the race, and the other ones are falling behind. Once that happens, if it hits a certain threshold, ESXi knows that, and it does a thing called co-stop. Co-stop. So back in the version 2 and 3 days, maybe even 4, I'm not sure. Co-stop means, okay, I got my 4 virtual CPUs here. All of you are going to stop right now. I'm not going to schedule any of you until I can find 4 available processors to run you on to make sure everybody gets caught up. Okay? So that's co-stopping is something we got to look for. That's bad. Okay? So that's bad. So I talked about skewed. I talked about co-stop. Well, if we're stopping everything, at one point we got to start them, right? That's what co-starting is. Oh, I found my 4 available processors, right? So let's clear that. Oh, I found the 4 available processors, and I can now do a co-start to start them up. Okay, that's kind of a drastic way of doing things. They've actually improved since version 4, even version 6. I think there might have been some enhancements in version 7 where we have this relaxed co-scheduling, but also we allow, we don't do a co-stop on everything. We won't say, oh, okay, because this one, because this one virtual CPU is running a little skewed, a little bit behind, I don't have to spoil it for everybody, so to speak. I could maybe just co-stop the 2 processors that are running ahead and let the other ones catch up. So we can still, whereas back in the old days, it was everybody stopped until we could find 4 processors. Now we can say, all right, you know what? I don't have 4, but I have 2 available, and these guys are skewed, so let's get them to get caught up to the other 2. So we have it. It's a little bit more relaxed, a little bit more forgiving now. But again, one of the big things you got to watch out for, remember I mentioned co-stop. Okay? I mentioned CPU ready. Okay? Those are some of the primary counters you want to take a look at. Okay? And by the way, I'm not going to cover every single possible counters when it comes to CPUs because, one, I don't know them all. I'll point out basically the ones that you should look for right away. Okay? All right, so the next couple of slides, I just want to get some terminologies out there. So this is a picture. This is actually a block diagram, an architectural diagram of an older IBM server, some of the stuff I used to teach way back when. And this is talking about uniform memory architecture. Excuse me. So what I want to point out, you don't have to worry about all this other garbage here. I just wanted to point out the processors. So you got a processor here, you got a processor here, these VRMs, voltage regulator modules. Okay, who cares about those? We don't really care about it. But you see the 2 processors are connected together via this bridge. Back in the day, we called this a north bridge. And we had south bridges. The north bridge was the fast bridge. It had the CPU and memory connected to it. The south bridge was like slower devices and serial ports, parallel ports, all that kind of stuff, whatever, right? We don't care about that. What I really want to point out to you is back in the old days, I don't think there's any servers doing this anymore today. This north bridge was a memory controller. There's your memory controller. And notice over here, you have your memory DIMMs. Okay? So there was one uniform memory architecture, one memory bus, both processors accessed. Pretty simple. Okay, that changed. AMD started it off first with, I think it was called their hypertransport technology. Intel came by with their quick path, I think it was. It doesn't really matter who, but anyways, I know AMD started it first. I noticed that first in some of their servers. Then Intel followed suite very quickly. You'll notice over here, I've got a CPU. Again, this is architecture of another older IBM server. We could forget about all this stuff. But I got 2 CPUs here, and you'll see there's memory attached to the 2 CPUs. So inside this CPU is now a memory controller. So it makes it really fast. Instead of back in the old days, we had to leave the CPU, adding latency to get to the memory controller. So it was really slow. And now we put the memory controllers inside. This is called the non-uniform memory architecture, or NUMA. I'll probably do a separate video on that because there's a lot of stuff we could spend time on. But don't worry, I'll cover the stuff that you should be aware of, kind of like the main things to watch out for. So let's go to this diagram here. All right, so here I got 2 sockets inside my server, okay? So I got 2 sockets inside my server. So I've got a chip in one of them and I got a chip in another, okay? And again, this one CPU here, the second CPU over here. Then you see each CPU has its built-in memory controller. That's right inside the CPU. Then you see the memory is plugged into the memory controller on each CPU. You ever ask yourself, especially if you looked at servers, why do I need to put in a second processor in order to use those DIMM sockets, those other DIMM sockets? I bought this server. It's got 8 DIMM sockets. I can use the first 4, but I can't use the second 4 until I put in the second processor. This is the reason why. This is a NUMA architecture. This is called a NUMA node. Okay, and this is another NUMA node. Okay. So when we talk about virtual machines now, ESX is NUMA aware. It is aware of that architecture. I know AMD's kind of done a few things here. I'm not going to get into it. I'll save that maybe for an advanced video. But anyways, ESX is NUMA aware. It knows about this. So in my picture right now, one of the things you got to watch out for, so here I created a virtual machine. Okay, it's got 2 virtual CPUs and 8 gigs of RAM. Do you see how this virtual machine fits really nice inside this NUMA node? It's got 2 virtual CPUs, so it can run on core 1 and 2, let's say, and it's got 8 gigs of RAM. My NUMA node here has 16 gigs on this side and another 16 gigs on this side. Best practice, and again, your vendors are probably going to say we don't support anything different, balance the NUMA node memory. If you got 16 gig on one side, you better have 16 gig on the next, okay? Doesn't mean it won't work if you did it differently, but your vendor who's selling your server probably won't support you. But anyways, today I think most people know balance the memory, okay? But where I was driving is this VM, again, needs 8 gigs of memory, 16 gig can satisfy it. So this VM here can sit entirely inside this NUMA node. Beautiful. That's what I want to see. How about this now? And that's 2 thumbs up. I'm only showing 1 thumb, but there's 2 thumbs. How about this one? In this example, I got a VM. I gave it just 1 processor in this case, so it could run on any of these cores. But notice I gave it 24 gigs of memory. Okay? That does not fit inside this NUMA node. So some of the memory will be over here in this NUMA node. Some of the memory will be over here. And this is considered, again, you see the thumbs down, this is considered a bad practice. Is it the end of the world? No, it's not. Is this thing optimized for memory access? No, it's not, but it will still function. Again, it's considered bad practice. So that means now when this VM, let's say it's running in this NUMA node, if it needs to access that other memory, has to go across this link to access that memory. And again, the quick path link, these are fairly quick. I can't remember what they are right now, but anyways, they're pretty quick anyways, but still it adds latency. So it has to access the memory over here and then come back. So it's not optimal, but it's not the end of the world. And again, like I said, I'll talk some about that when we get into the memory lecture, right? So now how I kind of look at this, it's not really the end of the world. Let's say to have good NUMA locality, let's say here's, let's go back to this picture. I always like to relate this to be whatever, shopping at Walmart, let's say. So in this example, I got good NUMA locality. This VM could run here. It could run over here. Again, I could move it over here if I wanted to. And it can be contained inside a single NUMA node, which is great. So try to relate this as, okay, so I've got, I'm going to Walmart on a Saturday afternoon. I'm going to buy some shampoo or something like that, right? So I walk in the door. I know where the shampoo is. It's right beside checkout number 1. I grab the shampoo. It's right beside that checkout. I check out. Boom, I'm gone. Beautiful, right? Really quick, low latency. But how about this now? How about, back in this example, how about now I go to get the shampoo. I go to, it's right by the checkout 1. So I grab the shampoo. I'm going to check out at checkout 1, but there's 20 people in line. I'm like, oh man, I don't want to stand here. And most of the times, again, they kind of make things better, but most of the times, if you look at the checkout number 20 at the other end of the store, most people don't want to walk the extra distance. And you'll see, oh, look at that, checkout 20 standing there doing nothing, right? How many times have you seen that? So I'm going to walk, grab my shampoo, I'm going to walk. Again, that's me going across the quick path, let's say. And then at that point, I'll check out at checkout 20, and there we go. All right. So it took me a little bit longer, but I managed to get out. Okay. So the idea where I'm getting at here is from a best practice perspective, size your VMs. Here, let's look at another one. How about this example? Somebody created a VM with 6 virtual CPUs and 24 gigs of memory. This has to run on 2 NUMA nodes. While it's not the end of the world, it will run, it will work. It's not optimal. Okay. So rule number 1 is look at the architecture in your server, understand the size of each node, how many cores in each node, how much memory. Ignore hyper-threading, okay? Pretend it doesn't exist. And then build your VMs to that size if you need to have a very large VM, okay? Try to keep your VM, so what I'm saying is try to keep your VM inside a single NUMA node. That is optimal. If you're building VMs that are so large, for example, in this example, I got 6 virtual CPUs, right? Um, let's say I had 24 cores here, right, inside each. So that would be 48 cores, right? If I was going to build a 32 virtual CPU VM, it would run in basically 2 different sockets here, right? So that will work, but always try to keep the design of the NUMA node in the back of your mind and try to build it as such. Now, how do you do that? For the most part, you kind of don't have to worry about that, but you still kind of do. All right. What will happen here is if your operating system is NUMA aware, which ESXi is, because that's what what we're talking about. When you build your VM, and let's say you give it 6 virtual CPUs, it's going to try and run this on that first node. Okay. If you create it with 8 or more virtual CPUs, ESX says, oh, I'm going to run this in 2 separate nodes. Okay. So it's going to try and mimic this architecture up to the VM. If the operating inside your VM is NUMA aware, which again, most are by today's standards, Windows, whatever, Linux, they're NUMA aware. They can take advantage of that, keep their processes running on a single NUMA node, right? So it will automatically do that for you if your VM has 8 processors, 8 virtual CPUs or more. But if it didn't, back in the old days, and I can't remember what version, you would have to go into when you create your VM and you say, I want to give it this many processors, you would say, I'm going to give it 2 sockets and then whatever, 2 cores. At that point, you're kind of mimicking this type of architecture here. So that was one way of kind of forcing it to say, I'm creating a 2-socket NUMA node, with 2 CPUs, and 2 cores inside each NUMA node. So that was a way that you could actually force that. I can't remember what version now it came out with, but anyways, once you're at 8 virtual CPUs, it kind of takes advantage of that and will kind of bubble up that information to your VM. So I'll talk about more on NUMA, especially when it comes to memory, when we get into the memory video. But be aware of this, and that's what NUMA is, non-uniform memory architecture. Basically, you have multiple memory buses. And I've seen some processor schematics or block diagrams. I think it was AMD. Please leave comments if you know, where inside your CPU core, you actually have 2 memory cores or 2 memory controllers. So in a sense, you have 2 NUMA nodes inside 1 socket. Anyways, that was a while back when I saw that. But anyways, so what are some of the things we need to watch for? Remember I talked about CPU ready? That's one that you have to watch out for. That's kind of a misleading counter, right? And I'll show you this, by the way, folks, when I do my demo in a minute. CPU ready doesn't mean, hey, the physical processor is ready, let's go for it. That's what you would think. Think the opposite is the VM's ready for a physical processor, but there's nobody there to help it. So that's a bad thing, right? So we want to watch this counter. Ideally, if that's 0, that's great. But you might see it a little bit higher. Numbers I've seen is like if this is at 10, that means you could be actually at that point struggling. This VM could be struggling for access to a processor. So that's kind of bad. To me, a yellow flag is like if I see 5, 6, I start questioning it, right? I don't freak out, but I start looking at it, right? Co-stop, remember I mentioned that? Co-stop applies to VMs that have multiple virtual CPUs. If you only get a single virtual CPU in a VM, co-stop means nothing. It'll be 0, okay? But co-stop basically says, I have to stop one of your virtual CPUs from running because I don't have enough resources to satisfy that. So what do you need to do? Well, there's a couple of things you could do. You need to move the VM onto another server. Again, any of these things. If there's a problem with processor, you can say, well, this server's overloaded. That one over there is doing nothing. Let's vMotion it over or use DRS. Okay, so those are options. But let's say that's not an option for you, right? Well, then in this example, maybe does that VM need multiple virtual CPUs? I see a lot of customers doing this and just says, oh, we got a standard where we give each VM 4 processors. And well, does it need it? If it doesn't need it, don't give it. You're making the scheduler work hard for no reason, right? So I know when we taught our classes, we said, ideally you only give it 1 processor and that's it. And if you need more, show me you need more, and then we'll give you more. Easier said than done because I know the real world's a bit different. Percent memory limited. This is again, this is what you want to watch for 0. the percentage of time the virtual CPU was ready to run, but was deliberately wasn't scheduled because it would violate a CPU limit. If it's larger than 0, the world is being throttled due to a limit on the CPU. Somebody put a limit on the CPU, and therefore there's a problem. That's going to drive this CPU ready, high, and more than likely co-stop, and I'll show you some of those. Now, physical memory use, CPUs, and physical CPU utilization. These are some counters in in ESX top, and I'll show you these. Generally, meaning this is the percentage that's being used of your physical processors that are being used. If it's greater than 75, now this is kind of a very blanket statement. If it's greater than 75, you may have an issue. If it spike into 90, that might be a problem. So a lot of people will go there first. What's the utilization of the processors on my ESXi server? If it's high, if it's 60%, 50%, that might not be a problem. That means that that server is doing work, which is why we built it, right? But suppose if there's a failure event, another server fails, and we got other VMs coming over, that might push that over the limit, right? So again, these numbers, you really got to think in the back of your mind, is this going to be a problem? But if I'm looking and I've got constantly high physical CPU utilization and the VMs are constantly waiting, that's obviously a problem, okay? So percent CPU used based on timestamp counter, clock cycles at a constant rate, not affected by changes in frequency. This other one is based on unhalted cycles, relies on clock frequency, power management, hyperthreading can influence this. So you might see these counters be slightly different. I generally don't worry too much about it. I just kind of look at it and see what the average is. So why don't we do this? Let's do a quick little demo using ESX top, and I'll show you a few things. Stick around. And by the way, if you haven't hit that subscribe button, please hit the subscribe button. And if you also haven't hit that like button, if you found this entertaining, hit the thumbs up. Let's see the demo. All right, we're back. So I've got a little demo set up here. If you'll see, I got a couple of VMs. I got an app, a database, web, and I got a Windows. These are all Linux machines except for the Win VM. Database also has a couple of processors. If I look at right now, there's actually I've got a little program running, actually a Win CPU busy script. That's and again, I showed you this back in my part 2, so stressing the processor, right? And I've run some commands on the Linux box just to stress those out as well, right? So again, you could use the GUI if you want to. Personally, I'm not going to bother. I'm just going to jump into ESX top because that's basically what I want to do. I got all of them, by the way. Let me click on host 1 here. Notice host CPU usage is a yellow alert on that. If I click on VMs, you'll see all the VMs are running on host 1. Okay, so I jammed them all on there, right? So let's go into PuTTY. Let's go to host 1 and let's log in. I'm logging in as root. And let me just change the font size so we can see this. I got a few things I want to show you as well, so you want to make sure you stick around, especially at the end. So let's hide that. Oh, what am I doing here? Anyways, so I've logged in. Let's, oh yeah, that's what I was going to do. Sorry about that. I got distracted. Let's go to change settings. Let's go to appearance. Let's change the font a little bigger so we can see it nice and easy. And let's go to colors and my default background, modify it. And I'm going to throw in something like that. It looks good. Apply it. There we go. Let's go full screen. I'm going to run ESX top. Okay. And right off the bat, ESX top brings us to the CPU screen. If you haven't seen this before, if you're not familiar with this tool, watch part 1 where I talk about the tools. So right now we're looking at CPU utilization. At the very top here, if I'm just using my mouse, you can see I've got, these are my averages over the last minute, 5 minutes, and then 15 minutes, right? You'll see that they're whole numbers, 1 point something, 1 point whatever. Great. And then if you look here under CPU used and CPU util, you see again 75. It's kind of dancing all over the place, but you'll see there's actually some high numbers here, right? Looks like a couple of them aren't doing that much. Anyways, there's some high numbers here, right? So I see all these processes running on the box. I just want to view VMs. Okay, I'm gonna hit Shift I'm going to hit Shift and then the letter V. I want a capital V. And it now shows me all the VMs that are running. Okay, you'll see my database, my win. Let me change my update. I'm going to hit S, the letter S, and I'm going to say update every 15 seconds. So it's not constantly updating. So you'll see database, app, web, and win. You'll see the percent used. We're at like about 200% over here in database. Wonder why that is, okay? And then you see the others are 40, 50. Again, nothing really to freak out about. Most people will look at this column and say, okay, oh, there's a problem here. Is there? I'm not sure, right? But you see something's going on and something's being used. Now, there's a bunch of other columns here you can look at. What we talked about was that percent ready. And that number that we said that's bad is anything over 10. Technically speaking, anything over 5, I'd kind of look at, right? But I wouldn't freak out. Notice all of them, percent ready 16, 49, 50. That's a problem, okay? So that means percent ready means the virtual CPU is ready for a physical processor, but the server doesn't have enough processors to satisfy that. Now, the other thing, so we see that there's a problem there, okay? And let me elaborate on that, okay? So now let's pick one of the VMs here. Let's pick database, because I gave that one two virtual CPUs. And I want to point this out. Notice over here, co-stop, it's 0.25, and they just went to 0.08. All the others are 0. Remember, co-stop is if you've got a multi-virtual CPU VM. It means I've got to stop your processors or one of your processors so the other one or other ones can catch up. Did you see the co-stop just jump to 17? Remember, this thing's scheduling stuff, descheduling stuff. I'm really pounding the crap out of my machine right now. I could probably do it a lot worse, but we want it usable so it doesn't completely lock up. So you see, there we go, it's at 31 right now. So the other ones are still at 0 because they only got a single virtual CPU. But again, all of them, their percent ready, where are you? Their percent ready is high. Okay. There's other counters here for idle, overlap. Overlap, my understanding overlap is the system had to go in and tell this machine to stop and then give processing cycles to somebody else, and then it came back, and that's kind of the overlap time. Generally, I personally don't really look at that. Over here, the percent swap, it's 0. I'll talk about swapping when I get to the memory. Memory. That's saying this is how much time the CPU is spent doing a swapping function, but we haven't talked about swapping. It's 0, so that's okay. All right. So generally, I look at that percent ready, the co-stop. Now, let's do something here. Let's look at database 1. I said that one had 2 virtual CPUs. Actually, before we do that, let's look at web 1. Notice the ID 393384. I'm going to hit the letter E to expand, and I'm going to type in 393384, and it just expanded that. You can see that right here. And these are all the worlds or processes running in that VM. So you'll see there's a config, there's a memory one, there's some threads, there's that mouse keyboard screen, there's a video. Notice the virtual CPU 0, right? There's looks like a disk controller one as well. So your mileage may vary depending on your VM. So I can actually look and see what's going on over here. I could see this CPU is being used quite a bit, and the ready's right there. It just updated on me. Okay, so there's that VM that I just expanded to dig down a little deeper if you want to do that. I'm going to collapse this. I'm going to hit letter E again, and I'm going to type in, again, that process ID, whatever, 393384. Hit enter, and it collapsed it. Let's look at the database one. Let's go E, 305-847. And you see it expanded it. What I want to point out here, there's 2 virtual CPUs there. All right? And I'm kind of stressing both of them. Now watch this. You see over here the co-stop, it was at 3.56 on the second processor, right? Remember, a lot of times it may, and it's now at 25.6 and 11, so it may be descheduling one or co-stopping one processor, letting the other one run. It really depends. So let's update this maybe every 3 seconds. I'm going to hit S to update, and then type in 3. You see it's at 2.9 and 17 now. It's at 9 and 11. Co-stop. So it's showing me, and then that other one got hit pretty bad, 21 and then 3, right? If we do S, let's do 2 seconds. Again, you see there is nothing there. Okay, now it's 0.4519. So it's going through the process of descheduling, scheduling, or co-stopping and co-starting processors so the other one can catch up. So that's not a good thing, all right? I'm going to hit E to collapse that 305847, 305847. Okay, so we see that we got a problem with processors. Now, the simplest solution here would be, oh, let's migrate the VMs off to other hosts. Now, in the real world, when you look and you go, oh, this one machine, this one VM has a problem, all the other ones don't, you need to go in. Like, for example, if this was a real world environment, I would look in and go, why are all these machines CPU intensive? I would go through each one and find out, okay, what processes are running? What's going on? Is this a database? Is somebody doing queries? So you got to, put on your Sherlock Holmes hat and start doing a little bit of digging, deeper digging within the VM. So if it was one or two VMs here that were really busy and the other ones were okay, I would be doing a little bit more digging here. Now, odds are, if it was one or two VMs, my percent ready probably wouldn't be high, okay? Stay tuned. Let me show you something, okay? I'm going to actually try something out right now, and I'm going to show you something. So stay tuned. We'll be right back. Okay, I'm back. So if we look here, what I did is I restarted some machines. I shut off the Win VM as well. You'll see Web 1 still here has a high CPU usage. Actually, if we look at my overall physical CPU of my servers, I only got 4 CPUs inside the server. It's a 2-socket, 2-core, so 4. And my average load over here is point something, right? Notice it's point something right now. That's the last minute. This is the average for the last 5 minutes. It's still at 1 point something, and then 1 point something for the average for the last 15 minute, right? So this is minute, 5 minutes, 15. So this will stay like this. It's 1 point something until 5 minutes from now, right? But we see right now the load's dropped off, okay? So it's less than 1, so that's okay. You'll still see Web 2 over here is still utilizing the processor, right? But the big trick here is now, notice ready here. Notice it's at 0. It just went to 0.03. We still see some ready here, percent ready, but it's small, 0.0 something, 0.0, whatever. Remember I said the number to watch out for is 10, right? Again, to me, I'd start investigating at 5, but I wouldn't freak out too much unless the VM's complaining, right? So we see that once I took the load off everything else, the percent ready went down. That means the VM is getting the resources it needs. Now let's look at App 1, for example. App 1, it's not doing anything, okay? The other machines are really doing nothing. Let me show you something. Let's go in. Let's go to App 1. Right-click on App 1. Let's go into Edit Settings. Let's go into CPU, and let's go into limits. Right now, I don't have a limit on CPU for App 1. I'm going to give it the minimum, 1 megahertz. This VM ain't going to like this much. I'm going to say okay. I'm pretty much making that VM useless at this point, giving it only 1 megahertz, unless it was a DOS VM, right? So that was App 1. Let's go back into ESX Top, and we see App 1. Again, percent use is still nothing. Okay, actually, let's give it a few seconds here. All right. Let the thing settle. I got to let it settle down for a little bit. Okay, it took a few minutes for everything to kind of settle down. Remember, I'm in a virtual nested environment. So App 1's doing nothing, right? You see the percent use is nothing. Notice the percent ready, off the charts. So I actually introduced or induced a percent ready. Now, how do I know that? Look at this counter here, the memory limit. I don't know why it's percent ML, MTD, whatever. That's a limit. I talked about that in the lecture component. Anything above 0 says somebody put a limit, a CPU limit. Let's set this thing to update every 30 seconds. So I went in and I gave it a limit. It says you're only allowed to use 1 megahertz of CPU, right? So its percent ready is like, wow, off the charts. So just looking at the percent ready being high doesn't mean, oh, there's an issue with here. Is you got to look at this column as well, the MLMTD percent, the memory limit or the limit, and see, oh, look, it's above 0. Somebody put a CPU limit on that. And that might be causing the reason or problem for that VM not getting its resources. Okay. Another reason could be shares. Remember, you won't see that on the percent MLMTD, right? But again, and I demoed this on the lecture 2, or sorry, part 2, shares, limits, and reservations. I can give higher shares to a VM, and I demoed that. You see, another VM was able to get more resources than the other. Okay, but that's basically about it, folks. All right, it's just a quick little high-level overview on CPU, a couple things, key counters to look for, and a couple things to watch out for. So I hope you enjoyed this. If you haven't subscribed to the channel, please subscribe to the channel. It does support the channel. It allows me to put out more videos. Leave comments and questions down below. Let me know if there's something you want to see. I'll be doing memory next, probably disk, and then network afterwards. But that's it. So subscribe to the channel. There's also the super thanks if you want to do that. Support the channel. Totally up to you. And hey, and share it around. Share the links to these videos with your coworkers or your buddies, because apparently that helps out with the YouTube algorithms as well. Sharing is good. Thanks again. See you in the next one. Bye now.